Okay. So now we have the same situation. Your friend flips 2 coins.
Yeah.
And does not show them to you. And then you select one at random.
Yeah.
Or your friend selects one at random, it doesn't matter. And shows it to you. Okay? So for example, maybe, and again, it's important to select it at random.
Yeah.
Okay, so maybe it's this one. So your friend says, hey, this one here is a head.
Yeah.
So maybe your friend flipped a coin and said, I'll do the left one or the right one, or maybe your friend, just flipped, just randomly labeled them 1 and 2, like I flipped this one first, this one second, and I'm going to show you the second one. Okay?
Yeah.
But selected at random, it shows it to you, and it's a head. The question is, what's the probability that the other one is a head now?
That seems a little like the last question.
Well, yeah.
So, but they selected it random.
Right.
So
Well, for starters, like the last problem, we can't have this situation. Because your friend showed a head to you.
Okay.
This situation is out.
and at least it shows at least one of them is a head. But we don't know which one is a head.
Well, it seems like this is exactly the same as the last problem. Because he could show this one to you, or maybe this one to you, and the other one's a head. So one out of 3 situations here, the other one is a head.
It kind of seems like the last problem.
Interesting.
Yeah.
But what if he showed you... But wouldn't there be like some repeat situations if he showed you... I'm going to get a better marker. If he showed you this coin, or if he showed you this coin, would these 2 arrangements be technically the same? And because if he showed you this coin, the other one's a head. But if he showed you this coin, the other one's a head.
Yeah.
If he shows you this coin, the other one's a tail. If he shows you this coin, the other one's a tail.
Yeah, it's interesting.
So is there overlap or isn't there?
Yeah. So is there overlap? Are we overcounting something here?
Because would these 2 technically count as one situation?
But does your friend tell you which one your friend picks?
All you know is they just picked one at random. Right? And it was a head.
Well, if we count these 2 as independent situations, then, and if we count getting a head and a tail as being different from getting a tail and a head, then how many do we have?
Because it's the first coin, there's 2 different coins that you're flipping.
Yeah.
And so these are, if the first one, the only way they would be the same as would be if you flip these. But you haven't flipped those. These are the possible situations.
Yeah, so it's actually pretty interesting. So one way you could look at this is you could say, as you say, these are head, tail, head, tail, tail, tail. But the question is, what do the columns mean here?
Well, you can see this is coin number 1.
Right.
And coin number 2.
Coin number 2. And see, you've seen coin number 1.
Or coin number 2.
Okay, well let's say maybe you saw coin number 1, maybe you saw coin number 2. Let's say it was coin number 1. Okay, so if it was coin number 1, you saw which situations were eliminated when you saw the head.
Well, then this situation and this situation are out.
Okay, so what's the probability that the other coin is a head?
It's 1/2.
Okay, now maybe it was coin number 2 that you saw.
Well,
Which situations are eliminated?
This one and this one. So
Okay.
it's still a half.
Still a half.
So it isn't the same as the last problem.
Seems to not be the same. And you could just say coin number, I'm going to call coin number 1. You don't have to call coin number 1 the same as your friend calls coin number 1. You can say coin number 1 is the first coin I'm going to see. Coin number 2 is the second coin I'm going to see. So the first coin I saw was a head, so it's either head, tail, head, head. Or you could think about it like this. Your friend flips 2 coins, randomly shows you one. Bang. What's the probability that this one's the head?
It's just 1/2.
It could be a head or a tail.
It's just 1/2. You didn't learn anything about this coin here.
No.
See, and the difference in the first one is that when I say at least one's ahead, you don't know if it's number 1 or number 2. You don't know if it's going to be the first one you
So
see or the second
if
one
they
you see.
reveal one, it's more probable that the other one's going to be ahead.
Or is it?
It turns out to be the case here.
But it could be different.
But it might be, that might not be a general rule. It's pretty neat that those two problems are different. That's a very important point in probability that can be a little bit hard to understand. But good problem for a quick little probability exercise this morning. Good work, guys.